section, we're going to look at the binomial model. The binomial probability model is useful for modeling certain common scenarios that involve discrete numerical variables. To be able to use the binomial probability model, we need to satisfy some conditions. First of all, there has to be a fixed number of trials. We're going to say n trials, where only 2 outcomes are possible at each trial. This is called a Bernoulli trial. You should think a success or a failure is possible at each trial. The probability P of a success is going to be the same at each trial, and the trials must be independent. So remember, that means that the probability of success at one trial is not dependent on knowing what happened at previous trials. Let's let X denote the number of successes out of the n trials. Let's look at an example. So suppose that we want to toss a coin 8 times and count the number of heads. Is this an example of a binomial experiment? Well, let's check the conditions. So first of all, is there a fixed number of trials? Sure, there's a fixed number of trials. There are going to be 8 trials. Oops. Are there only 2 outcomes in each trial? Yes. At each trial, we're going to flip the coin, and we could get heads or tails. Is the probability of a success the same at each trial? Here, a success is going to be getting heads because we're interested in counting the number of heads. And the probability of getting a heads at each trial is always going to be 1/2 or 0.5. And are the trials independent? Yes, the probability of the second flip isn't changed by knowing whether we got heads or tails on the first flip. The binomial distribution is defined by the values of n and p. So remember, n is the number of trials and p is the probability of success at each trial. So here's our probability binomial distribution for the example of flipping a coin 8 times and counting the number of heads. Okay, so here n is 8 and our probability of success was 0.5. This highlighted in red is showing us the probability that the number of successes is less than or equal to 3. A binomial distribution is going to have a symmetric shape if the probability of success is 0.5, but it will also have a symmetric shape if n is large, even if p is different from 0.5. So here on your screen, you've got on the left a binomial distribution with a probability of success 0.5 and a fixed number of trials of 15. On the right, we have n equal to 100 and our probability of success p equal to 0.3. In both cases, you can see that these are symmetric distributions. However, if n times p is less than or equal to 10, or if n times 1 minus p is less than or equal to 10, then we may expect to see a skewed distribution. So here you have 2 examples. On the left, if we multiply p equals to 0.01 times an n of 200, we're going to get 2, which is smaller than 10. And you can see that this distribution is skewed to the right. So here's our skewed right. On your right, we have a distribution where if I multiply n, 80, times 1 minus p, I get 1.6, which is less than 10. And this distribution is skewed to the left. The spread is further to the left.